Good evening, sir.
Hello, Bhavana. Am I audible? Hello, Bhavana. Is it audible?
Yes, sir.
Alright. So I gave you some problems yesterday.
So, like, I didn't got the topic at all. Can you explain me from the starting?
Alright. Uh,
So, this
okay,
differentiation part,
okay. I'll teach that. So should I
not
like
the answer, like the topic, I didn't get it.
topic it? Alright. So basically, differentiation means dividing things. Okay.
Okay.
In this chapter, like in this topic, we will be dividing a long thing into very small portions, smaller chunks. You can call it. So basically, all the differentiation is all about not about the dividing into chunks. I have brought it a little bit incorrect. It should not be like this. Differentiation is about um, computing the change of first parameter with respect to second one. Okay, with respect to second one. If I give you two parameter, let's say y, and another is x, we can have any other parameter also. Let's say u and v also. So here it's all about like which parameter I'm taking for a reference and for which one I'm looking about the change. Okay, so let's say I'm saying let's take v as a reference. Mean to say, with respect to v, okay, with respect to v, I'll be checking how much my u is varying. Okay, this is what in differentiation we are looking for. So if this is my y graph, y axis, and this is my x axis, okay, it's a simple thing that if I make a random curve like this, okay, you can see my x and y is varying, right? Can I see that? But their change is not a linear thing. Linear meant to say, let's say, zoom a little bit more. Okay, slowly put down here. Okay, if you see carefully, if I take this point, okay, if I'm taking just very small portion this one, okay, let's take this. If I take this as a small portion, if you see carefully, if I ask you what is the change in this region, you will say for this small amount of dx, my y has been changed by this parameter. Is it
Yes.
okay? If I go to at the other point, let's say this point, you can see this distance. Okay, maybe if I can try this from here to here. Yeah, width is exactly same, right? So I can say this distance I have taken the same thing. But let's measure the y parameter. So if I'm saying this is the y variation, Okay, look, this is your y has been changed by this time. So you can see your y is has been changed by this parameter, right?
Yes.
Where is that scale? I need here. Do I have any option for scale? No, I don't have. Okay, let's say this is 2 meter. I want it to measure properly, but I don't have any scale for now. What we can do here? Okay, let's do this. So you can see this is my width here for this change, and this is the height, right? If I take the same
Yeah.
thing over there, you can see for the same width, for the same x change, I have a different y change, right? Here my y has been changed only till here. There I had the total change. Here only this much is changed. Is that clear?
Mm.
So this is
Yes.
what we use to figure out for every given equation in the differentiation. Okay. If you see, we call this as dy by dx. In general, dy by dx basically perpendicular thing divided by base thing. It's not an uh, regular thing. You can also do dx by dy. What does this mean? I
Okay.
am I am looking for the change in, okay, wait, I wrote it x by dy. I am looking for change in x parameter when my y
Okay.
has been changed by a smaller unit. Is that clear?
Okay.
Okay, so I'll make 2 or 3 curves for now. Uh, So let's say my another curve is this one. Okay. For this curve, if you see carefully, let's say I'm taking this here, small, what is it? Small triangle. Same triangle, if you see, I can take here also. Same triangle, I can see, I can take here also. You can see in this particular case, for the same for the same value of dx, I have same, like I have some value dy. Here you can see I have the same dx, same dy. Is it same dx,
Yes.
same dy? So what I can say here, this is representing my change. It means if at all the points, whatever you are checking, if I'm checking at this point also, you will see my dy comes out to be constant. Is that clear?
Yeah.
What does this mean? That whatever the change I am having in dy by dx, this is in a constant value. Understood?
Okay.
Okay. Is it really a constant or are different values there? Okay, this
I
is a
think it's
constant value.
constant.
It's a constant, right? Look, if I
Yeah.
just go back to my equation, what is that? If you see, we had an equation like y equals to 2 times of x or something, right? Let's write it as a times of x. Okay. What does this mean? That
Okay.
this is a given as an equation. Okay, so you have already studied from your 10th that linear equation. So you know how to make graphs, right?
Yeah.
So this will give me a linear graph. The linear graph, if you plot this, I'll just plot it over there. Okay, we have proper scales also, so it will help us. I'm using the upper equation. Assume y is having some value. And just change the color of this page. Now it makes sense. Okay. So in this graph, if I just take this line again, so this is thing. Okay. As per this equation, let's say a is equals to 2. The value of a is 2. So this is my equation for now.
Okay.
0, 1, 2, 3, 4, 5. Let's beat till here itself. Okay? When I'm putting my x equals to 1, like when I'm putting x equals to 0, what is the value of y? 0. For x equals to 1,
Zero.
y comes out to be 2. For x equals to 2, my y comes out to be 4, and so on, right?
Yes.
This I can say. For 3, it comes out to be 6. So I will just make some points. For this x, I have 2. For this 2, I have 2, 3, 4. And here on for 3, I have 6. And so on, maybe 8, 10, and so on. If I just plot this over here, you can see I've got a straight line, right?
Yeah.
Now, you have two options. Like, okay, if I just wanted to have a change over here, so I'll take another smaller block. Let's say we take this one. Not this one. Take this. So if I'm taking this one, you can see uh, this is my width first. This is my width, and I'm looking for the height. So let's do for the height first. Now can you see for this small dx, I even know the value of this dx route. That is 1. I have a
Yeah.
y as a this much, right? 2 change. It means if my y has been changed by 2, like if my x has been changed by 1, my y has been changed by 2. Is that clear?
Okay.
Here I don't need to go with the dy by dx, because I can also say, because this is a bigger value, right? So I can say if this is my y value, what is this y value? This is y. So I can say what is this value? This is y plus something extra, delta y.
Yeah.
Can I say this is the extra value? Here, if I'm saying this is my x, I can call this as total as delta x, x plus delta x, right? So how much has
Yeah.
been changed? So I can say final minus initial will give me the change. And that is very clear thing, that final is y plus delta y minus initial is y. So I can say, yeah, this is change. That is fine. Okay, but if I just ask you what is the slope over here, so you will say it is nothing but tan theta. For if I'm saying this is theta, what is this? Perpendicular, right?
Yeah.
Perpendicular. What is the perpendicular for this reason? You will see it is nothing but that is delta y divided by delta x. Clear? Because this was a bigger picture for me, and it was a constant. Even I take this bigger diagram over there. Let's
Okay.
say if I take this bigger diagram from here in this, like this, still my answer won't be changing. Okay, if you see, if I take this one, what was the value over here? This is the value of y, right? 1, 2, 3, 4. 4 initial, final is 6. So 6 minus 4, 2, and this is difference is 1. So what I am going to get? 2 by 1, 1. Change is 2, right?
Yeah.
If I take the bigger example, this is 2, 3, 4, 5, 6, 7, 8 divided by, no, I think that this total is 8, right? Minus
Yeah.
maybe 6. And here, this whole thing, what is it? 1, 2, 3. So I can say divide by 3. Can you see, like I have got two answers. The reason is,
Yes.
even if I go with the equation, I can say delta y by delta x. Okay, I will be computing for different values. Okay, so you can say I'm getting two values. Another way, I can simply go to very smaller element. It's a very random or smaller element, and if I check for this one, what I'm going to get? D times of 2x is there divided by x, and what I have got here, I can rewrite the same thing as
Yeah.
got. Now, this method is okay if some like normal equation is given to you, but what if some equation is given to you which you are non which you don't know about? For example, if I make a very random curve, I'll use another page for this one. Okay, the page is visible, right?
Yes, sir.
Okay, let me know if I'm writing something. And this is this page. So, example 2. In this example, I'll be taking another curve such as okay, and from here I have another point. So yeah, that is the thing. Now I wanted to make curve. Let's say I have made a circle over. Can you see this circle?
Yeah.
I'm just creating a circle over here. So that's the thing. Now, if I ask you what is the slope at this point, so I'm really not sure what is the slope at this point because the reason is very simple. If I try to reach this point, I have two different values of y at the same point. Is that clear? If I'm
Yes.
at this point, I have one value here, one value here. Okay.
Yeah.
If I reach this point, I have one value for y here, another value for y is this. For
Yeah.
single x, I have two values of y. Reason? The equation of circle is basically x square plus y square plus 2ax plus 2by plus c. This is the equation of circle.
Yeah.
You can see it is not depending upon a single parameter. Earlier, if you see, I had a single parameter this. Okay, this is a
Yeah.
quadratic. Quadratic means to say you will be having two values. Basically, for each x value, you may have two values of y. For each y, you may have two different x. Right, right. Let's say I'm talking
Hmm.
about this y value. Okay, this y you have this as one x, this as another x. Okay,
Yeah.
okay, that is fine now. I will simplify this equation to just a single parameter equation, and this only happens when your circle is formed at the center. So this is the point.
Okay.
If your circle is formed at the center, so equation is this. That equations become x square plus y square equals to whatever the radius is. So if I say this is the radius of the circle, okay, not like this. Mm, So this is the radius of circle. Okay? If it is now, you can write it as r. Yeah. If I ask you what is the change,
It's
if I ask you what is the change, so you know for the curve, the direction. Basically, if you see in the previous question, I had this as an example, right? So you see how I was calculating the change. I was calculating the tan theta, right?
yes.
Basically, if you calculate the tan theta, you will be getting this perpendicular thing divided by this thing. Okay, it's up to you. You can change the thing. Okay, if you want dx by dy, just calculate tan theta and reverse it. Understood?
Okay.
Actually, it won't work like this. For some other equations, we will see that as an example also.
Oh,
Or it can work. Okay, leave it. So yeah, where I was in this case. If I just move at this point, I say what is the change? But if you see, this is a curve, right? Not like a previous equation.
yeah.
So I can say I'll just go and make a. I will try to create some square box. So I tried to bring a square box, but there's a
Okay.
problem in this square. That this value is not a constant, right? You
Yeah.
can see it is varying. Like wherever I am reaching, do I have option to minimize this? No, I think not. Not fun to achieve. Yeah, leave it. Okay. So if you see what I do, if look, there's two options to calculate. One, I can go for a bigger picture. If I go for a bigger picture, I am looking for a curve. I'll go a little bit more small. I will again get a curve. I will go a bit more. The more and more I am increasing, I am seeing my curve is getting into the linear equation, right?
Yes.
So look, in the previous equation, I could have easily calculated for this delta y by delta x. But in these cases, then when the things get very small, what I need to do that I have to go for a very small picture and get a dy. Here from I have to get a dx. Understood?
Okay.
dx and dy. Now if I ask you what is the change, earlier my at this point my y is this, right? After moving from here, like, okay, at this point my y is this value. After moving from here to here, my curve is getting downside. So if you just move in a very smaller picture, you will seeing like it this. Okay, what does this mean? It means my x is increasing but my y is decreasing. Is that clear?
Yes.
Okay, that is fine. But if I say, if you just go to the same y value, no, actually in the mathematical magnitude wise it is decreasing. So this is the significance of your dy by dx. Is that clear?
Okay.
It will get you the change also. All right. From here also, I'll just explain you minima and maxima also. If you see,
Okay.
okay, wait a minute. I'm just making some points. Okay. Look, let's talk about the trigonometric. You know, I every time told that this is the angle made by the curve, right? Whatever we are seeing over there. If I'm saying
So
this
I
is my,
can't see.
wait, uh, can you see this? Bhavna, can you see this? Just try to rejoin. Maybe you will directly get to my screen. Hello,
No, so I
Bhavna.
can't see.
No, I'm saying just try to rejoin the session. You will get to my screen after this.
Okay, okay, okay.
This happens in this board.
So is it like example and the graph?
Yeah, yeah. I'm just giving the graph an example also.
Yeah, I can see now.
Okay. Look, this is the angle, right? So for this angle,
Yeah.
this is the theta, tan theta. I can say tan theta is nothing but my dy by dx. If I say my theta, if you see, for some value of dx, if my dx is increasing, dy is increasing, you can see my d theta is increasing, right?
Yes.
Okay. And if so, I can say if my d theta is increasing, what does this mean? That my graph is going in this way, right? It is increasing. Can I say this?
Yeah.
If my d theta is decreasing, can I say my graph is going like this? The reason, let's talk about the reason. You know, I generally calculate the theta from here, right?
Yes.
So if you see, my graph is right now at this point. What does mean? I'll be looking like this. Okay, understood? You have two options: either do it like this, or either do it like minus thing. Understood?
Okay. Okay.
In this case, if you do this, tan theta. Okay, in the first class, if you could remember, all of them are positive in this region. Sine is positive in this region. Tan is
Yeah.
positive in this region. Cos is positive in this region, right? So I can say cos
Yes.
tan. You see, my tan has reached this region. Mean to say, if just draw a line, it has reached this region. Mean to say, whatever the value you are going to get for this is negative. Is that clear? And this is what,
Yeah.
if you reach here, like if your curve goes like, for example, if I make curve like this, and if you calculate tan theta for this, you can directly do it like also this. Wait a minute. Let's say this is tan theta, right? We are taking this section as positive. If you go back side, this is negative. Is it?
Yes, sir.
If you do this, like basically the angle you are going to get, that will be in 0 to 90 degree, but in a negative thing. If you do that like this, you will be getting angle in like 270 plus value, but whenever you put the value, you will getting the same answer. Okay. So look, if you get
Okay.
this thing, you will be having something like tan theta, tan of minus theta, right?
Yeah.
You know, this can be written as sine of minus theta, cos of minus theta. And we have already
Yeah.
studied that if there is negative in the sign, that can be taken outside, mean to say minus of sine theta. If something is inside the cos as a negative, you can remove that negative, right?
Yeah.
So whole thing becomes tan of theta. So basically, if you just go by like this, let's say the whole thing is somewhere around 330. Okay, if you do 10 330, or other option is go as a negative value 10 minus 30, because the from this side it will be minus 30 itself, so this will become
Okay.
minus 10 30. The answer for both is same. Understood?
Okay.
All right, so let's run for a while again. Yeah, so I was at the change. Let's look at it for a while. Okay, so basically I was saying your d theta, this is giving you change, right? Now if I'm just making a very random curve. Okay, if I make something like this, and if I make, let's say this is A point, B point, C point, D point, E point, F point, G point, E point, K point, and all. If you notice carefully, all the top, very top values are like this. Is it?
Yeah.
What is the angle made by this line with the x-axis? Zero, right? Basically, your curve is going like this, decreasing, decreasing. There is some point when it reaches exactly aligned with it, right? Let's say this is the
Yeah.
mi x-axis and it gets aligned. Isn't it a zero? The angle is zero. If it would have
Yeah.
been like
Yeah.
this, it is zero right now. Okay. And what is the value of 10 0? 10, 10 0? Zero, right? We are not interested
Yeah.
in that. I'm interested in slope. This tan theta is known
Okay.
as slope. Okay, so this tan theta is known as slope. So can I say for all the height, whatever the graph you are given, all the maximum values, like not these are local maxima, okay, not the real maxima. What is the real maxima? This, the max, no, not this actually, somewhere here. This is the maximum value of the curve. Okay, basically for varying x, this is the maximum value in the whole curve. Can you see this? Either this or this. Is it?
Yeah.
These are called as a local maxima because this is also maximum value, right? If I ask you what is the maximum value in this region, you can say this is the maxima in this region. Is it?
Overall, that's last one is the
Yeah,
maximum.
overall that is last one. For example, I can have another curve also, like in this is local maxima even for this whole region, but this is
Yeah.
the main maxima. Okay, understood?
Yeah. Yeah.
This is called as a maxima or maximum value. This is called as a local maximum, or you can add global also with this. That is a global maximum. In a similar fashion, we have called as a minimum.
Yeah.
Okay, what does by minima? This in the similar way, just like we have noticed for the maxima thing that slope goes to zero, for the minima also this slope goes to zero. Understood?
Yeah.
Don't say that this is the minimum. The reason is from here curve has started. Okay,
Yeah.
understood? And differentiation is basically, differentiation is about the slope. And if I ask you what is the slope at this last point, I can't calculate. The reason is it is ending at this point. And to calculate
Yeah.
slope, I need the direction, right? And for a single point, I can have a multiple directions. So how I will decide the slope? Understood my point?
Yeah.
Okay. For slope, I need some curve or some line so that I can make a proper slope and I can say, okay, dy by dx. If you say get me the slope at, if I ask you get me the slope at this point, in which way I have to make curve so that I can calculate dy by dx. Okay. So this is the reason
Okay.
differentiation is only possible for continuous curve. Okay,
Okay.
continuous also it doesn't mean that I can also say that this is also continuous curve, right? No, not this. Let's minimize it again. This is also continuous curve. Uh, this is also continuous, but this is a pointed point. Can you see this?
Yeah.
If I wanted to make tangent at this point, for this point I have this, I have been multiple tangents. Okay, tangent is basically the line perpendicular to that curve. Okay,
Yeah.
If you assume that point as a curve of some radius, so the line which you will be making perpendicular to that, you should know the tangent, right?
Yeah.
Okay, that's fine. So basically, differentiation is not possible for, and write it here also. Differentiation for non-continuous curves and pointed vertices. Okay,
It is only possible for curved, like.
it is only possible for curve or the continuous one, because here you
Okay.
can also say here it has been breakdown. It has been break. Okay, so you can't find out the curve points. Okay,
Yeah.
let's discuss. Let's come back to maxima and minima. So the first point is maximum. Okay, you got to know that the maxima is a point where my curve is having a. If I'm saying this is my, if this is my curve, okay, not with this. If this is my, okay, no, this is my curve. Okay, maxima,
Okay.
local maxima. Okay, if you see,
Yes.
if you just check the minima, minima is also having the slope dy by dx equals to 0. Clear?
Yes.
Basically, the value will come out to be 0. I'm not sure whether theta comes out to 0 or not, but the value comes out to be 0. Or one more thing.
Okay.
Okay, so for now, you got to know that for maxima and minima, the slope comes out to be 0, right?
Yes.
Let's talk about increasing or decreasing. Okay,
Mhm.
just check this one. In this curve, you can see this is the increasing path, right? My value is increasing. This is my
Yeah.
decreasing path. This is increasing path. This is decreasing path. Decreasing in something, I can say this is a constant. It looks like constant. Something you can notice about that. For my increasing path,
So your
my
voice is
curve is like
breaking.
this. Hello, is it fine now? Still breaking? Bhavna, is it breaking a lot?
Hello.
Hello, hello, Bhavna.
Yeah. Yeah, sir. You're
Now
audible
it's
now.
fine. Okay.
Yeah.
I'm saying, if you see carefully, if I'm going from here to here, my value has increased, right? If I went from here to here,
Yeah.
my value has increased. And if I calculate the slope, you can see I'm getting positive theta. It means my tan theta is positive. Is that clear?
Yes.
What does this mean? Increasing value of curve. Okay? Increasing curve. All the points which are decreasing part, you can see they have tan theta is less than 0, decreasing. Is that clear?
Okay.
And for tan theta, which comes out to be 0, what does that mean? Either they are the maximum value, either they are the
Minimum.
minimum. Maximum or min. Okay. That is the thing. Understood?
Okay, sir.
Okay. Now we can just go for some another thing, that is, okay, it's done. Okay. Now the twist is, if I ask you what is the, let's say I gave you some curve like, okay, let's take the example of the circle which I made earlier. Okay? This is the circle, and I have made it for the, okay, let's create it very center of it, just assume this thing. And I have created it at this point, as a, taking this point as a center. Okay. Now, if I
Okay.
ask you what is the maximum and minimum value of y for this curve, you right now you can see, okay, if I say this is 1 2 3 4, this is the maximum value. Okay, and this is the minimum value. Minimum mean to say, because it is a negative side, right? I can say this is a minimum,
Yeah.
is it?
Yeah.
But you have not given this. You are just given this equation: x square plus y square x square plus y square equals to maybe 5 or 6, I can say.
Okay.
Um, let's say some radius r because I have not given the value here. Now, if I ask you what
Okay.
is the maximum value, how I can identify it? I know one thing. If my dy by dx comes out to be 0, I can think of something maximum or minimum value, right? So let's do it.
Yes.
If I differentiate it, what is this equation? You can see I need y. This is written in this equation. So I will convert this into the y. How I can do that? I will take y this side, x square plus r square. Is that clear?
Yeah.
But I need dy by dx. Let's do it. Okay. Why I will let you know after this. If you see, I can write this differentiate the whole thing. Okay. What you are going to get? You have two options to differentiate it. One is you can do just take y is like this, and okay, you can differentiate it. If you do this, what you are going to get answer x square plus r square, and this is power 1 by 2. And you know this r is a constant value, is it?
Yes.
Okay. And this is 1 by 2. So how I can solve? First thing is to calculate the power.
Yeah.
I did it, and take the rest part as it is. After this, solve the internal. If you solve the internal, then you will be getting 2x plus differentiation of this part because it is positive. So I can do it in a two parts. So I will get 2x for x square, and for this one I will get 0. Is that clear? So
Yeah.
I will get the answer is 1 by x. I got this. Now I am getting dy by dx equals to 0. This thing. This equation I am getting, okay? 1 by 2
Okay.
x square plus r square. And what is it? 2x. Is that clear?
2x.
Now I have two options to do. What are those options? The option is if you see the curve carefully, okay, wait. I made a very small mistake. The mistake is that, mm,
So is it that x square plus r square only?
no. Look, yeah, it is x square plus r square. It should be
Yeah.
minus 1 by 2. Okay, the reason
Yeah.
is it is 1 by 2, then minus 1 will give it to you. So this thing will become how much? 1 by 2x divided by x square plus x square. So you know this is the value of dy by dx I'm getting. It means, can I say this is nothing but the equation of slope?
Yeah.
It means if I put the value of x, I will get the slope at each point. Is that clear?
Okay.
So, okay, we can remove this 2 by 2. What I have got? X square plus r square
X.
and under root 1 by, okay, x is also there. Under root. Okay, this is the equation of slope I have got. It means
Yeah.
if I put this value, I'll be getting the different value of x. Or if I put the different value of x, I'll get the slope. Is that clear?
Yes, sir.
Okay. So I can have you example also. If I put the x equals to 0, if I put the x equals to 0, the whole thing will become 0. And what is the slope? 0. If you see, at point 0, I have two slopes. One is this, another is this, and both are 0. Can I say?
Yes, sir.
Okay. You know this is my radius, right? If I put x equals to r, you can see my slope should be undefined. Understood?
Okay,
Why
sir.
I'm saying undefined? Because we take the slope from here, right? So you can see the angle is this. What is this? 90 degree. 10, 90 is nothing
Yeah.
but 1 by 0, which is undefined. Okay? So let's put the value.
Yeah.
I have got this value. Okay, I'll put x divided by x square plus r square under root. And what I had to do here? Yeah, I had to keep x divided by, no, it should be r, right? R divided by r square plus r square under root. Wait, why I'm not getting it? It is coming out to be and 1 by under root 2 times of what is x?
So
Uh,
how can you take r square?
what?
How can you take r square?
No, I have not taken the r square. Basically, this is the radius given to me, right? So I am saying I wanted to calculate my slope at this point x. Okay,
Okay. Okay.
so this is what I wanted to do. So I have just substituted the value of x equals to r over there.
Okay,
in the
okay, okay.
equation. So I'm getting something like this, but do I have done any mistake over here because I'm not sure. The slope should have been 0
Mm,
at this point because this is 1 by x under root this. So mm, no, it's wrong actually here. I'm getting the wrong value. If I keep x equals to 1, is it really the equation of
s-
the
So, like, I think it's
I
like
don't know.
x square,
It's x
r
square.
square minus x square, or x square minus r square, right? So, if you transpose it, how can it be plus?
No, no, actually, wait a minute. The question is like this itself, and okay, wait a minute, right? When I went with this side, it should be x square, is it?
Yeah,
So this is the mistake I did. So it will be minus, negative, negative. This goes okay. So yeah, negative is there. Just assume negative is there. I'm looking at minus. Okay. Now you can see I have a negative. This comes out to the zero, undefined, right?
yeah,
So I can say this equation can give me the slope of curve. I will write it like this. But what I needed, I wanted to get the value of maxima or minima. I needed to both things. Okay. So if you see how I can do this, I know this is the equation of curve. Okay, but what curve I need? I need zero. I need slope as zero. So if I put
yeah.
x is equals to zero, I will get the value of x at which my slope is supposed to be zero. Is that clear?
Okay,
If you see here, if I put zero, I will get x equals to zero. Just go and back check the equation. Where is it? Yeah, not this. Let's check the graph. In the whole graph, only this point is there when I have a slope as zero. Apart from this point, I don't have any point where I can have a zero slope. Is that clear?
okay,
Understood. Okay, that's fine. Now I will go back and put the value of x in the curve. Okay. Now you can see I have a dy by dx. Okay.
yeah,
This is giving me slope value. I already know the slope value. I had an equation. I just got the value x equals to zero, where I can get my slope is maxima or minima. Is that clear?
yeah,
So I'll put the value of this x equals to zero in my equation. So this is x square plus y square equals to r square. If I put the x equals to zero, I will get y square equals to r square, and y will become plus minus r. Is that clear?
okay,
Although here, if you see, I have two direct things. One is r, another is minus r. So I can say this will be my maximum value. This is my what kind of value it
minimum
should
or
be? Minimum value. But because here I can directly get, but what if the equation is such that you can't figure out by seeing the values? In that case, how you have to figure out? You have already got the value where you can have a maxima or a minimum. Is that clear?
yeah.
Okay, just assume you have given some equation, and they are saying this is the point given to you. Let me know whether the point is of maxima and minima. Okay, and you are given all as variable. Then how you can figure out whether at this point I am get whatever value I am getting. Let's say here I have got two values. Let's say you are getting single value r. Then how you will figure out whether this is minima or maxima?
So if it's positive, it's maxima, right?
Uh, okay, let's go back and what if I made my whole curve and the downside? Wait, this is my y-axis. This is my x-axis. I have made my whole curve downside. The
Yeah,
maximum value in this curve which I can get is, let's say this is 3 value minus. So the maximum value which I can get the whole curve is minus. Now can you tell me whether it is maxima or minimum? Are you
it's
getting the point?
maxima only, right?
It is maxima, but I
Yeah,
said I don't know the curve, right? I have just given the curve, and I wanted to know whether this point is of the minimum or not. For example, if I have given a curve like this, okay, and some point x is given to me, let's say this point, okay, and
okay,
another point I can say this. 2 points are given to me. If I calculate this one, and I wanted to know whether the point is of maxima or minimum. because when I put the value, I will be getting something negative value over here. Is that clear?
Yeah.
I can get the same negative value here also. So I can't say na whether this is maximum or minimum. No, it is a decreasing value. This point is
Yeah.
increasing value. Understood? So what are
Yeah.
the parameters how I can decide whether it is minimum or maximum? So if you see carefully, I need to go for the slope now. How much slope is changing? Are you getting my point?
Yeah.
Till now, what I discussed is how my equation is like how my curve is changing, right?
Yeah.
But if I get to know how my the slope is changing, for example, for this curve, I have a higher slope. Let's say for each point I can make another. Let's say for this point I have some slope as very high value. Okay, let's say here. After this, some value similar to this. But you can see it is decreasing. So can I say my slope is decreasing? If I make the slope curve, it is decreasing because it curve is like this. Mean to say here it's like this,
Yeah.
like this, like this. So can I say my slope is
Yeah.
decreasing? So can I say it will go like this
Yeah.
down? Look, the reason for the downside. Wait a minute. I'll just show you. My slope is increasing here. This is looking like that. Is it?
Yeah.
So if I make the curve of this slope, not the equation. Equation is like this. Okay. This is this curve of the equation. Wait. I will go with the linear first. Let me check if the page is sufficient or not. Let's use another page. I'm writing something. Let me know if it is visible.
Okay.
Is it visible?
No, sir.
I'm noticing. Um, just rejoin it again if possible. Yeah, that page not there. I think.
So, have you drawn any curve?
Yeah, just one curve is like this.
Yeah, I can see.
Okay, now look. Look, I have to take another class also, so I'll take it a little bit fast. Okay.
Okay. Sir.
Okay. Hmm. This is my linear equation. This is my another linear equation. Okay? And let's say
Okay.
this is my curve. If I check this point, I will get my changes. What? Okay. Here I will plot my slope versus x. Okay. In this plot, I will be plotting if how my x is changing, like how my slope is changing with respect to x. Is that clear?
Okay. Sir.
So let's say you for the linear equation, the slope is constant, right?
Yeah.
The slope for this equation is true. I can say when my curve is zero, let's say remove start from this point, at x equals to zero, at x equals to one, my slope is two. At x equals to two, my slope is again two. At x equals to three, my slope is again two. So you can see my slope is constant. What does this mean? If my slope is a constant value, it means my whatever the equation is, it is either just increasing or either just decreasing. Is that clear?
Okay.
Understood?
Okay.
It means my curve is just increasing in a same pace. But if I make curve
Okay.
like this, if I make curve like this, let's say till here it is fine. After this, it went like this. So let's say this is point something around 1, 2, 3. After 1 to 3, my slope was like till here, same. The moment it gets like this, so can I say this is a decreased value of slope?
Yeah.
So I should put slope little bit downside, is it?
Yeah.
After this again, at this point again it is like this, and after this some point you will be having like this. Can I say like this, and suddenly it goes to zero?
Yes.
Because make it little bit more. It is like this, okay, and I am looking for the slope. So if I say this is my slope, one, slope, slope, You can see these are representing some theta value for each point, okay, not just a single point, each point. So can I
Yes.
say in this region my slope is decreasing?
Yeah.
Okay, fine. So I can do one thing. The reason, what I can do is, I will go and check the slope, okay, at each point first. So if you see, let's say this was the point, okay, here it was decreasing. The moment after it, my slope is still decreasing, right?
Yeah.
Because it is decreasing, decreasing. Let's say decreased, and after that it gets constant. Let's say this is so it will be like this. So can you see this is the point where my slope is decreasing? Like when my slope is zero, this is the point where slope is zero, is it?
Yes.
This is the point of maximum point, right? Where my curve is maximum.
There.
But if I take the slope of the slope itself, that is negative. Understood?
Yeah.
You can see my slope of the slope, mean to say angle made by the slope itself with respect to x is negative. Is that clear?
Zero. Yeah.
Negative, negative. Understood. So can I say something that whatever in the previous case, let's say, look, to get the maximum and minimum, what you have to do? First of all, you will be given the curve. Is it?
Yes.
Get the slope. From the slope, you will be getting f dash x. You know that f dash x means differentiation of d, like whatever the curve is with respect to some parameter. Okay, is that
Yeah.
clear? Okay. By this equation, if you want to get the maximum minimum, look, if this equation comes out to be negative, positive, whatever, it will tell you whether it is increasing, whether it is decreasing. For example, this will give you curve equation. If you put the x value, you will get the increasing or decreasing value of curve. Understood?
Okay, sir.
Whatever you will put in this equation value of x, it will give you increasing, decreasing, or zero value of curve, not the slope. Understood?
Okay.
So if from here you are getting negative value, it means your curve is decreasing. From here, if you are getting a positive value, if your curve is increasing. Is this clear for now?
Okay.
Now,
Okay.
but I don't want this. I wanted to know whether the value I have is maximum or minimum. Just assume the question says give me the maximum value. So you will put this equals to zero. If at some point, if like let's say you are getting one something equation is 1 by x, after differentiation I'm saying I need slope equals to 0. It means I when I put this, you can see x equals to infinity, undefined, right?
Yeah.
When I can get this value, I will get this value, mean to say there is no possibility of having slope 0. Is that clear?
Yes.
Understood? So
Yeah. Because
uh,
it's infinity.
yeah, it is just increasing, right? For
Yeah.
example, if I take
Yeah.
this curve like this, okay, what is the slope here? Dy by dx. That is two value, right?
Yeah.
You can see I can't make this dy by dx equals to 0 in any way. It means I will be never having any maximum value. I will never be having any minimum value. Is that clear?
Yeah.
Downside it
Yes,
will
sir.
be getting decrease, decrease. Upside it will always getting decrease, increase, increase.
Yeah.
But if I make some other curves, these I can have. So let's say I'm not taking this value for now. I'm taking this curve y equals to x square. Okay.
Okay.
So this curve gives you something like this. Understood?
Hmm.
Wait, if I put x equals to 0, I make that value. So let's add a here. When you add this a here, now what will happen here is this y gets shifted by a little bit small margin. Let's say this. So this is the
Okay.
value of a over here. Now I wanted to look for the maxima minimum of this curve. Okay. Just
Okay.
assume you don't know what is the curve. You are just given this equation. Okay. Let's see. I am asking, give me the maxima and minima value. I am asking both values. So what you can do, you know a simple method that I have to go for the slope and I will differentiate it. If you differentiate dy by dx, you will get 2x. Okay,
Okay.
makes sense. So what I should do now? You can say I wanted, I want maximum minima. I know at maximum minimum my slope is 0, so I'll put it equals to 0. Okay, I got one thing that
Yes.
at x equals to 0, I will get my maxima and minima. But I'm not sure
Yeah.
whether I'm going to get maxima value or minima value. Is that clear?
Okay.
How I should do now? One option is just put the value. If you put the value, what you are going to get? Let's see. Y equals to x square plus a. If you put x equals to 0, let's say something, and let's assume a is equals to 2 here. Okay, so this distance becomes 2, 2, and if you just put the x equals to 0, y you are getting 2, right?
Yeah.
If you go with the theory that if by putting in equation I'm getting positive value, it will be maxima. If it is negative value, it will be minima. But here you can see I'm getting
Minimum.
positive value, right? But for
Yeah.
this curve, this 2 is the minimum value you can ever have.
Yeah.
Then how I should do? I will try to make curve of the slope itself. Okay, understood?
Okay.
So let's
Okay.
start from here. This is here. I'm here. When I am at x equals to 0, my slope is 0, right?
Yeah.
I'll use red pen for this. Let's say this is. After this, when I move little bit this side, you can see my slope has increased by a small margin, or it is just increasing.
Yes.
So I can say it is increasing, right? How I should
Yeah.
make it? In this side it is increasing, so I'll be like, okay, positive, positive, positive side is increasing. It makes sense, is it?
Yeah.
Because after this you can see the curve is actually like this, so it is just increasing and increasing, and after time
Increasing.
you can see some point will be like this straight, the maximum value 1 by 0, which is generally infinite, right? Okay,
Yeah.
let's check the downside in this side. If I check the this side also, what is the slope? Slope is increasing. Increasing slope means like this, is it?
Yes.
Okay, what does this mean? That it means my slope is increasing, right? What does this mean that slope is increasing?
Maxima.
Minima. Look now, maxima you will get. Here was the maxima, right? When your equation was increasing, suddenly look how look if your curve is getting increased,
Yeah, yeah, yeah. Slope is getting increased, so it's me.
if slope is getting increased, the value is minima. Understood?
Yeah, 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 yeah.
So
Got it,
if
sir.
you just if let's say I'm saying this dy by dx is nothing but s. Can I say s because it is my slope? Now I will
Yeah.
do ds by dx. So if I do this, what I'm going to get, I will get 2. 2 means I don't have any option to put x equals to 0. It means my slope is always, what kind of slope I have? Always it is increasing. Understood?
Increasing. Yeah.
Where it is increasing? Except 0 point, except this point, it is always increasing.
Yeah.
Understood? You can also say at this point it is 0, so both sides it is increasing and increasing.
Okay.
So this is what we can think of it in a way.
Okay,
Is
sir.
that clear?
Yes.
Alright. So this is the thing. So one thing is clear. If the slope, if the differentiation of slope comes out less than 0, what I can say equation is, I can say whatever the point you have chosen where your ds by dx comes out is less than 0, that point is maximum. Understood?
Okay.
And ds by dx, if it is greater than 0 for some x, then x is minimum.
Okay.
Is that clear?
Yes, sir.
So this is all about the thing. Okay. Um, any like, do you have doubt like in differentiation concepts?
No, sir. Got it.
Is it clear, right, in today's class?
Yes. Yes.
Okay.
Yes, sir.
Do you want me to discuss those formulas which we discussed yesterday?
Sir, next class?
Yeah, next we do because I have to take one more class also.
Yeah, yeah, sure, sir. Thank you, sir. Sir, shall I leave?
Yeah, you can.
Okay, sir. Bye.
Uh, but